Learning with people. I'm April, and I'm going to explain the second part of the evidence. So the first problem says they are asking us the frequency, the time. We have angular frequency. I use the frequency formula. There's angular frequency over 2p. So I put the values in the formula, and the result of frequency, it's 39.45, and the time is 0.025 seconds. Then we have the second problem that they are asking what is the speed if the displacement is 1 millimeter. So we have frequency, amplitude, and distance. We're going to use the max speed formula that is 2p times amplitude times frequency. So I put the values in the formula, and the answer is 4.14 meters over second. So then we have the third problem. Before starting having the units, like current units, for example here millimeters to meters, it's really important, because if you don't have the correct units, you're not going to have the correct result. So you need to remember that. So we can start. In the third problem, they are asking us to work the decompression force and the potential energy. Well, the formula for work is force times distance. We don't have force, so we can calculate. As you can see, this is the formula. We have all the values. So we have force, we have our formula, we replace it, and here's the result, that is 0.23 joules, because that's the work unit. Then they are asking us the potential energy. This is the formula. We do have all the data they are asking us, so we put our data here, and the answer is 0.116 joules. Then we have the fourth problem that I think it's really easy. They are asking us the speed of a transverse wave along the wire. They are giving us the mass, the longitude, and they are giving us force or tension. So the formula I use for calculate speed of the transverse wave, the speed is same of the square root of force over that is string density. So we don't have that value, but there's a formula to calculate, that is this formula, that is mass over longitude. We have both values, so we can have the string density. Once we have this value, we can complete the formula by putting the force here, 100 over the density, that was 1, and the result is 10 meters per second. That's the velocity of the wave. Then for the fifth problem, they are asking us the mass. So you need to use this formula, that is linear density, this mass over length, but we don't have this value, so we're going to use this formula, as you can see, to know what's the linear density. Once we do we put the data in, we're gonna have linear density. It's equal to 300 over 150 elevated to 2. Then we can do this like equality, that this is the same as mass over distance. So we put all what we're asking for, the mass, put it here, we substitute, and we're gonna finish with this final formula. So you need to do all the math, and then the result, its mass is same as 0.053 kilograms. Then we have the next problem that is asking us how long does it take the sound to travel. Well, so we have our formula for velocity in a piece of road that, as you can see, it's this. So we have these values, that is length, density, and y. So we substitute, and the velocity, as you can see, it stays like this. Here we put the values. So this velocity is equal to, velocity is equal to distance over time. So instead putting velocity, we put this. We have we need to we want to know what's the time. So we're gonna pass the distance, that is time first here, multiplying, and then this over the distance. So here's what I just told you, and here's the answer, that is 6.85 times 10 over elevated to minus 4 seconds. That's the answer. We have the next problem, that it is asking us the sound from 55 decibels horn is measured at a distance. What is intensity? Well, it is asking the intensity. So at first we need to calculate, or we need to know what's the intensity for human hearing. It is this value, as you can see. Then we have the decibel scale, that is the formula, as you can see, put here. So we have all the values, so we're gonna use this formula. We want to know the intensity, this one, not this, because we already have this. So as you can see, this is equal to 55. It's equal to 10 times log times intensity over the human intensity, as I told you. So we're gonna do all this math to leave intensity alone. As you can see, what we did, the 10, we press it to this way. So we're gonna do, all we're gonna do is to, as you can see, really clear, we leave the intensity alone, because that's the thing we want to calculate. So the answer is gonna be, intensity is equal to 1 times 10 elevated to minus 65, and we have the units that is asking us, as you can see, and then we're done. This is the result. Then we have the next problem, as you can see, and it is asking us two values. First, the frequency of the listener when it passes, that means when it's nearby and when it's far. So we're gonna use just one formula, that is frequency heard by the listener. It's equal to speed of the propagation of sound times frequency emitted by the source over speed of propagation of the sound minus or plus the speed of the source. That's the formula for moving source. So as you can see, we put the first one minus, because this is for the one it's approaching. So the result for the one it's approaching, it's 588.48 hertz when it's approaching, that is this one. We use a minus because in the formula it told us if it's approaching, we're gonna use the minus. Then for the one it's moving away, it's gonna be 534.14 hertz. Okay, then we have the last problem. They are asking what are the frequencies of the sound of the observer hears when the metro passes by. So you remember that at the beginning of the video, I told you to convert, to be sure your units are in the, for example here, we change kilometers to meters per second, because that's the velocity unit. Once we have all our units in the right unit, the unit we need to use for the formulas, as you can see here is a conversion chart. We're gonna use the formula for moving source, the last one, just like we did on the last problem. So for the first one, it is when it's moving away. So we're gonna use the plus. We're gonna put 330 times 343, that is the speed of the air, over 343, that is speed of the air, plus 20, and the result is 311.81 hertz when it's moving away. And then the result when it's approaching is 350.43 hertz. It's the same formula but different sign. For example, for when it's moving away it's plus, and when it's nearby it's minus. That's only for the moving source. Thanks for watching. This was Learning with April. See you in the next video. Bye.